Okay, so welcome to the last session of Eclipse conference. I'm Lorenzo Bettini. I'm a researcher at the University of Turin, and I'm also an ITEMIS consultant. And I'm also a committer for the Eclipse project EMF Parsley, which is implemented in Xtext, by the way. But today, I'm going to talk not about how to implement an Xtext language, but how to test your Xtext language while you're implementing it. First of all, are you all familiar with Xtext? Okay. So the motivation. I saw many people that use this workflow while implementing Xtext. They modify the language, they run the new Eclipse instance, and they try manually if everything works. That's definitely the wrong workflow. It's not very productive. And we should write tests instead. And it's quite easy to write tests for your language with Xtext because it provides a nice testing framework, okay? I'm going to use an example that you find on GitHub. And I'm going to use this very simple expression language, nothing fancy. You can declare variables and standalone expressions, and then we have some generated Java code from the input language. And that's quite trivial, but still it's a nice use case for testing, okay? So you start with a grammar in Xtext. First of all, you start with simple expressions which are constants, and then as soon as you go to the recursive expressions, you run into trouble because Xtext does not support left recursive grammars. That's not a big problem because there's a known technique, left factoring, for avoiding left recursion, but it might not be that easy to get it right, at least the first time. So that's a good starting point for testing. The parser, first of all. And we also especially test that the associativity of the expressions is correct, and also the priority of the expressions are correct. So Xtext already provides you with a starting point for testing because it generates a plugin project only for tests. You know, Xtext uses dependency injection under the hood, and so it also generates some injector providers you can use during testing. So first of all, we will see that we will be able to test most of the aspects as plain JUnit tests without running a workbench. And that's cool because JUnit tests are much faster than running a workbench. And this is the typical test case. And I'm going to use Xtend in the whole talk. Everyone familiar with Xtend? Okay. So Xtend is what they call it a better Java. So it's kind of a Java with less syntactic noise, with more advanced features like type inference and lambda expressions. It compiles into Java and it's completely interoperable with Java. So you can use all Java libraries from Xtend. So even if you don't know that, you can read it quite well. For sure, it's easier to read than Java itself. So the idea is that the test case has to be run with this specific Xtext runner, a custom JUnit runner, injected with the generator injected provider. And then in the test case, you can inject the utility classes from Xtext framework. And now we will see how we use that. First of all, we will use the parse helper, which allows you to easily parse a string with your grammar, and it returns the AST of your language from the parsed string. What we are going to test is not only that we are able to parse a program correctly, but that the associativity of our expressions is correct and that the priority of operators in our expression language is correct, okay? And that's very, very important, not only because we are testing the parser, but because most of the time as a developer of language, after parsing the language, most of the time you will walk in the AST. So you really have to make sure that the AST has the structure you expect. That's why it's important to start testing from the parser. So how can we test this? Given the AST of the parsed input file, we create a string representation that highlights the structure of the model. And we check that it is as expected. So given any expression, we'll give a string representation with parentheses that tells me how the original expression is parsed. And given this representation, I can check that, for example, the priorities are as expected. So multiplication has higher priority than other operators. And also that associativity is as expected for operators of the same precedence. Okay? So you see that it's quite easy to write readable tests that test what you actually expect. Okay? So feel free to interrupt me at any time if you have questions. Now let's come to the validation. Of course, after parsing, you have to validate your model. Let's say that in this DSL, I want to avoid forward references. So I don't want an expression to access a variable before it is defined, just as an example, okay? So usually you do that in the validator. What I would suggest to do is to write a separate model util class that only performs this specific task. So given any expression, it returns the list of variables defined before that expression in the program, okay? I know it seems easy. I mean, it just walk in the AST, but even in this simple case, it's not that easy to get it right the first time, okay? You may want to try that. There are a few exceptions. And the idea is that, so we are not writing the validator yet. We test this class separately. And then when we're sure that this class works as expected, we pass to the validator. And again, it's easy to test it. So we just call, as I said, I'm not showing the implementation, I'm showing the tests. Okay? The implementation can be found online. So for example, I make sure that before this expression, there are no variables. Before this expression, there are no variables. Before this expression, only the variable I is returned, and so on, okay? This way, I'm sure that my class works as expected. And since we're there, why not starting to do some code coverage? Do you know Eclemma? Anyone know Eclemma? Okay. So it's the Jacoco integration into Eclipse. And since although we write extend code, it's easy to code coverage the generated Java code. So extend generates readable Java code. So this is generated by extend, but it's easy to check that everything is covered. So once we are sure that the tests work correctly, that we considered all the possibilities, that everything is code coverage, then we go on and we go to the validation. So now we implement the validator using this utility class, and you see that the validator is also quite easy. So that's the only piece of code of the implementation I'm going to show. And so I generate an error on a variable reference that refers to a variable which is not defined before the expression. Okay? How to test this? There's no need to run the workbench. Okay? We can use this validation test helper from the Xtext testing framework. Okay? So it's quite easy to use that. We don't need the workbench. And just by injecting this class, we can assert many things. So given this input program, I expect an error on this variable reference, okay? Because it's a forward reference. And I can make explicit all these requirements. I'm saying that I expect an error on an element which is a variable reference, I expect this error code. Not only that, I can also say that I expect the error on this specific part of the program. So I specify the offset and the length of the element in the original program where the error marker is expected to be put, and the error message. So I'm testing the validator without running the workbench. So although I am a guy from the type system community, I'm not going to talk about type systems today. I'm just telling you that also in this example, you have to perform some type checking. You have to check that the expressions are correct with respect to types, that you're not multiplying a string and an integer, for example. Okay, so again, don't do that in the validator directly. Write a class which implements the type system, test the type system all by itself, and then you perform the type checking in the validator, and you test the validator as we saw before. Now, the interesting part, code generation. So in this example, what I want to do is that given any input file, I want to generate a Java class with the same name of the input file with an eval method. And for each variable declaration, we generate a Java variable declaration. And for each standalone expression, we generate a system.out.println statement. Okay, nothing fancy. How do I test this? Here, there are a few more setup steps to do. First of all, this is implemented in Xbase JUnit testing framework. I'm not going to use Xbase, but I need to add these dependencies to my testing plugin project. I'm also using JDT core because we will use JDT compiler in the tests, and we will use this compilation test helper, which is a really useful class to perform tests about generated code. You may want to have a look at the example because there's another small adjustment to do. But so I can inject this compilation test helper, and what I can do is that given this input, I expect that the generated Java code is this one. Okay? So you see that it's easy to test that given an input file, the generated Java code is as expected. Okay? I think that it's quite also readable as a test. It gives you a kind of formal specification of your language. Okay? Of course, if the generated file is not like that, you get an error, a failing test. But another important thing is that you can do more. Just by calling this method, you can check that the generated Java code is actually correct Java code. So just by calling this method, you will trigger JDT compiler, which will compile in Java the generated Java code. And if the generated Java code is not correct, the test will fail. So you have the opportunity to test also that you generate correct Java code, because that's important. Okay? And that's my favorite one. You can do even more. You can also you can compile the generated Java code and instantiate the generated Java code and run the instantiated Java code, so that you can check that not only the generated Java code is correct Java code, but that it behaves as you expect. And I think that's very important. So in this case, I expect that B will print true, this expression will print false, and this expression will print this on the standard output. Okay? And so now I can test many things on my code generation. And most importantly, as I said, I can test that I generate Java code which compiles into Java and that it behaves as I expect. Again, I've never used a running workbench up to now. Okay? All these are plain JUnit tests. But we can also test UI components, okay? I think one of the most important components to test is content assist. I mean, if you're using Xtext, it's because you like to have a nice Eclipse editor. And you also like the fact that you get content assist for free. But you want to make sure that the content assist behaves correctly, okay? And it's rather easy to test this because you have a base class for tests for content assist. So you just have to extend this class, but now you have to use the injector provider for UI, because this time we have to run these tests as JUnit plugin tests, because now we're testing the content assist and we need a running workbench, okay? So make sure to give enough memory to this launch configuration. And with this utility class, it's rather easy to test it. You have this nice API for testing the content assist. For example, here, I'm testing that at this point of the program, I expect that the content assist propose me I, okay? You see? I can also do more. I can also assert that all these values are proposed by the content assist. So now I need a running workbench, but again, I'm writing JUnit tests. So I'm not testing manually. So let's tweak the content assist, because the default content assist would propose me all the variables in all the expressions. But we can do better, because we have to avoid that the content assist proposes variables which will make the program incorrect. So it makes no sense to propose forward references, and it also makes no sense to propose a variable in this context of type string, because it would be incorrect, okay? So we can tweak the content assist. I'm not showing how to do that, but then I can test that the new content assist behaves correctly. You see, I can put a cursor in the program with this convention. So I'm saying that in this part of the program, I expect that I is not proposed. And I can do something similar also for other cases. And that's quite an easy way to test the content assist. We can also test the integration with the workbench. So this time, these are real integration tests. I want to make sure that given a correct file of my language in a Java project, the source gen folder is generated, and what I generate in that source gen folder will not generate any error marker in the project. I can use this class provided by Xtext, abstract workbench test, and Xtext also provides some nice utility classes to programmatically create projects in a workbench. And then I can also use the core resources standard methods for accessing the workbench. So what I'm going to do is that I write a test with a setup method. I create programmatically a Java project using these utility classes. I add the Xtext nature, of course. Then I can write a reusable method that creates a file in this project, waits for auto-building. That's nice. I mean, the test will wait that the running workbench has finished to build automatically. And then I can use the standard technique to find error markers. Okay? So I can use this method. Given a valid program, I expect no error marker. Given a program with an error, I expect some error markers. So here I'm referring to a variable which does not exist. So I expect an error marker. Finally, the outline. The default outline is not very nice. You see, you have children in the tree which do not make sense. You know that in Xtext it's quite easy to customize the outline, so let's customize it like that. How can I test that without manually running Eclipse? So unfortunately, there's no utility class, but it's easy to write one, and you can find the code of this class in the example. And I'm going to propose this class as an addition to Xtext. And if you use this class, you can say, given this input file, I expect that the outline is like that, just with a string, okay? And here you're testing the outline. I think in a quite easy way. So as I said, we are able to test most of the things as plain JUnit tests without running any UI. And that's important because if you take this example, it has 72 unit tests, and it only requires 2 seconds and something, okay? We saw that we have some UI tests. In this project, we only need 8 tests. 8 JUnit plugin tests, but you see that these require some more time because the workbench has to be run, and that requires some time. So if you can test something headlessly without the UI, please do like that. It makes things easier. So going to the headless build, if you're using Maven Tycho, then you have to specify 2 execution configuration. One for the tests that do not require UI, so you have to specify false in this case. And I'm telling you that if your DSL, that's not the case, but if your DSL has to access external Java libraries, then you will go into troubles with this approach. In that case, what I would suggest to do is to using Maven Surefire plugin for these tests. So not using Tycho, and then usually the tests will work. For the UI test, you have to configure that you are using the UI harness, and you have to specify that you're running in the UI thread, okay? So it's not the case of this DSL, but in a more complex DSL, you would like to test other aspects like quick fixes or hovering, okay? Unfortunately, Xtext does not provide any class for that. But if you have a look at the Xtext sources, you can find many inspirations. That's what I did for the outline test. You have to consider that that Xtext has many tests. Okay, so they test basically everything. So you can draw some inspirations from how they test things. So other testing frameworks, especially if you want to do functional tests, you know that Eclipse provides many frameworks. To be honest, I've only used SWTBot. So I have no experience with these other tools. But usually I use SWTBot in my Xtext languages to test more advanced functional testing. So if I provide a project wizard and I want to make sure that that project wizard behaves correctly, I'm using SWTBot. And I'm strongly encourage you to have a look at Expect, which is a testing framework for Xtext developed by an Xtext committer, which provides, I don't have time to go into the details, but if you have a look at the demo, it's quite impressive because you test your language in quite in a much easier way. So please have a look at that project. And then, of course, you use CI. Okay, Jenkins is my favorite. That's what I'm using. That's basically the Jenkins job for this very example. You know, Jenkins gives you some nice statistics about failing and successful tests. And you can also have reports of Java code coverage. I know this is a very simple example, but you can reach 100% code coverage. I know that that's not a guarantee, but for sure I think it's a good starting point, okay? So of course you can't rely on that, but if you don't have a nice code coverage, then, well, something might go wrong, almost for sure. Or you may want to have to try Travis. Anyone familiar with Travis? Okay, just two. So it's rather easy to set up a Travis file. This one is for this example. So I build also this example in Travis. And I think we are at the conclusion. So yeah, some advertising. Okay, so that's my book on Xtext, and it's not just advertisement, it's just that there's an entire chapter about testing, okay? So this talk is inspired by that chapter. And so please evaluate this session, and thanks for being here, and if you have questions. Yeah?
One of the things when you generate code for non-Java code or other stuff, with almost every change on the generator, the code changes. So to adapt all test cases, and again, we stopped it because it was undoable to create, to maintain the test suite we have for the code generation.
So I'm repeating the question. So you're saying that the code, the tests for generated code are fragile, right? Because if that's true, but to be honest, I think it's really important to have full control on what you generate. So I know that tests become fragile, but I think it's better to be sure that what you generate is really as you expected. That's also what, some of the Xtext committers recommend.
And what we now usually do is that we now compare to previously generated.
Oh, previously generated.
We have some reference from places where we expect code, and then based on that, evaluate the result of the generator, because maintaining test cases was just stopped because we couldn't maintain it.
Well, for sure you could have not many tests for generated code, but at least some corner cases tests. So just for the most important one. At least you can still check that the generated code is compiled correctly without checking the actual generated code. You can still do that, and that's already something. At least you know that what you generate compiles fine in the target language.
For Java, you have constructor methods.
Yeah, are you generating C?
Yeah, combination.
Well, yeah, then it might be more complicated, but you can still set up the compiling stuff for the target language. That's what I would recommend. Because you have to be sure that what you generate is correct generated code.
My question is general. Why extend and not another language? Why extend and not another language like Ruby?
Like? Well, for sure you can use other languages. The fact is that this testing framework is for Java. So, and you could use Java. the fact that is that with Java everything is much more verbose. So what they propose you to do is to use Xtend to have much more readable test cases. In the end, you can use whatever you want. If you want to use this testing framework, then you have to use Java or any language that is interoperable with Java. Any other question? Okay, so thank you.